Okay. So thank you for being patient, guys, while we were testing something out for another session. So welcome to our May 29th Fun Hour. I'm your host, Audrey. And again, please remember to keep yourself muted when you're not talking. And if you have any questions, just send us a chat in the Zoom. Again, there will always be a reminder email the day before the event and also a follow-up email afterwards. So here is a link for our Folding at Home, our fundraiser, which you can donate to. So this Sunday, May 31st, there will be a parent information session if you're interested in joining ACP Robotics because they have started their recruiting process. So again, the link to these slides will always be sent out later, but we have a QR code and a link to register if you want to join their group and participate. So, okay, I'm going to disable.
Come this way. Come this way.
So today, the online resource I'm going to be introducing is Microsoft MakeCode. And what it is a free open source platform where you're able to do computer science experiences, activities, and projects. It actually doesn't require an account, but you can create one if you want your work to be saved. I think one of the best things about MakeCode is, you see on the picture on the right, all the different options for what you can do. Can you guys please mute yourselves if you're not talking? Thank you. So you can actually learn how to program and write your own code. It's either in blocks or JavaScript, and you get the option, for example, for Microbit, EV3, Arcade, and Adafruit. You can run the program that you wrote in the simulation to see how it runs virtually. And you also have the option of downloading it onto a physical hardware. And I have an EV3 robot right here, and I will show that in a minute. So one of the options you can do on MakeCode is called Arcade Game. And if you go to their website, this is what they walk you through in the very first tutorial. As you see on the top, you can write the code in either blocks or at the bottom in JavaScript. In this first arcade tutorial, you're able to write this pizza game that I will show you. So as you see, Arcade is all about you learning how to write a program for a game. As you see in the video, this was actually on a simulation in the web browser, but if you have arcade hardware, which you'll see in a second, you actually have the option of, again, downloading your code and running it onto your hardware so that you can physically play the game you coded. So Arcade on MakeCode actually has a lot of resources available. They have everything from tutorials, live streams, learning computer science introductions 1, 2, and 3. You can also learn game design concepts and watch videos on how to design your own game. So on their hardware, as you see, they have all these options available, and they're pretty inexpensive as well. So you can get any one of these and go to MakeCode, learn how to write a program for a game, and actually download your program onto any one of these sort of chips and play your game. So for today, I will show you an EV3 demo. First, I'll show you the code, how it works in the virtual environment in MakeCode, and then how it works in a physical robot I have here. So I'm going to go to MakeCode. This is kind of what the platform looks like. They even have Minecraft here, so if any of you guys are interested, you can definitely check that out. So I'm going to go to the EV3. Okay, And then this is a project that I already have created. So I know many of you guys, some of you guys definitely have experience with EV3. Some of you guys probably don't have any experience at all. We do have this little pop-up on the right that has basically a quick introduction on it. So again, you can write it in blocks or JavaScript. Their blocks interface is actually very intuitive. So as you see, this code I've written, when the touch sensor is pressed, which is this little red cross over here, they should run both motors at 25% power. And then when the color sensor detects white, the robot will stop its motors. And when it detects black, the motor should run the opposite way and also show these little googly eyes on the screen of the brick. So on this left is the simulator. If you click this little play button, you can actually test out your code. So if I press the touch sensor, you see the motors at the top are running. Now, if I press white, then the motors stop. And then let's say I want the color sensor to detect black, then the eyes will show on the screen and then the motors are running the other way. So that's how it looks on this simulator. And I'm going to download it. I have this robot that's connected with the USB cable to my laptop already. So how you get this program onto this hardware, in this case, it's an EV3 brick. I'm gonna click this blue download button. Okay. Okay, I'm not sure why my taskbar isn't showing up. Okay. So I won't take any more time, but how it should work is that after you click the download button, you should open File Explorer, and then you're going to move the file that you downloaded into a folder because your EV3 brick is connected with the USB. And then once the file is copied onto that folder, you can actually test out your program. I think if it works later, I might show it. But for now, I think we're going to move on. So next we're going to go on to Builder Zone, which John is going to present.
Audrey, can you clear the screen?
Oh, wait, do you mean these lines?
Yeah, before you disable, it was already there. So I guess there's an option to clear. Yeah.
Oh, okay, I got it. Let me try the demo again this time. So this is the file that was downloaded. And as you see, this is the EV3 folder. So we're going to move that.
Okay, we don't see your screen. We see your presenter screen.
Can you guys see the video? So as you see, the motors are running. Press the touch sensor. They start going the other way. And then I have this sort of block right here. One side's white, one side's black. So the motor stopped when it saw the white. And then I press the touch sensor. It goes the other way. And then we detect the black.
We didn't see it.
Wait, can you guys see the video I'm showing?
I can't.
We can see, we can see your video camera. Maybe you want to disable sharing and then doing your spotlight.
Yeah, I can't see your screen. Okay, now.
Okay. So this has a touch sensor right here. Then you see the motors are turning the other way. And then this block I have, if the color sensor senses white, it stops. And then has a touch sensor, it's going to run the other way. And now if it senses black, the motors are going to turn the opposite direction. Okay, so let me share my screen again. Okay, so I think MakeCode is a really great resource. And the simulation does look a little bit different. If you guys were here in our first robotics hour, I introduced the Amazon Future Engineer, and that was kind of like a 3D virtual EV3 robot that you could see move. But here it's mostly 2D. So what you're limited to is essentially testing the logic of your program. You can't exactly test if your line following is going to work or anything like that. So now we're going to move on to Builder Zone, which John is going to present.
Okay. Can you get to the next slide? Okay, so this is a counterbalancing spring. It's a constant force torque spring, and it's basically a roll of like spring steel, and it generates force when you bend it backward over another drum. So like the constant force basically feels like a tape measure, if you don't know what that is, or don't know what it feels like. And so we got them from Vulcan Spring, which was donating them to first teams. And so we had email communication with the vendor, and we used this design document, you can see on the right, to like help design what we were going to do. So you can see there are 7 different torque ratings that we can get. So our calculations called for a 4.17 pound and 1.5 pound spring with a 0.6-inch spool to lift our linear lift system, which we use the springs for. Next slide. Okay, so this is the calculations that we did. It's a long, complicated equation, but basically it takes as input the weight of the linear lift system, which you can see it as W, and the gear ratio, which is R. So the weight of the lift system, which is about 20 pounds, you can see, minus the force of the spring divided by the spool diameter, which is acts like a gear ratio. And as you can see on the left, the graph is has the Y value as like the speed of the lift, and the X value is the diameter of the spool. So then you can see at the apex of that graph, you can see the fastest speed we will be able to get if we have a 0.588-inch diameter spool. Okay, next slide. Okay, so we had to make a prototype to get the outer diameter of the spring because it's different based on how you mount the spring. So on the top right is our prototype in CAD. We don't have any pictures of it, but it looks very similar to the picture right beneath it. And so when we CADed this, a lot of the dimensions were from the design sheet, as you might be able to see on the sketches on the left. So sketch on the left, there's the storage drum on the left, two spools. On the right, there are 2 spools again. And then on the top and bottom, the extra spools. One is to spool to lift up, and one extends when it goes up and retracts when it's going down. Get 2 direction. Next slide. Okay, so the prototype showed that an inset was needed for the springs, or else when they wrapped around, they would be elliptical, not circular. And the vendor said that can actually break the spring. So on our actual CAD, we add an insert to the spring so that the screws can be in there. And then we also CADed these support structures on the top and bottom. And these add 2 points of contact for all the spools, which eliminate the sideways forces and like make it much more efficient because there's no misalignment. And these were made in CAD simply with the sketches on the left. And actually on the bottom part, it, even though it's supposed to be circular, it's made like rectangular, and I kind of cheat a bit with using the fillet tool to get curved edges to make a really like a square with really curved corners. Next slide. So like all things, it went through a lot of iterations. The calculator, it assumed it had like a constant 20 pounds of force, but actually because the strings were stretching, it actually, the lift could lift up like a couple of inches before the full 20 pounds kicked in. So we had to reduce the force of the spring first to only the 4.17 pound spring. Then we reversed the smaller spring to get 2.67 pounds. So in the performance, going up, it still traveled faster because the help of the springs counteracted the gravity. And then down, even though the lift still fell and it wasn't like weightless as we were like planning for, it still fell much more gracefully instead of like slamming down as it did before. Now for a live demo.
Okay, so Audrey, disable sharing and spotlight John.
Okay, so this is the spring, and you can see it turns whenever the spool turns. And this is the lift that it powers. And you can see, like, this is like 5 pounds, and even with that, it falls like quite slowly because of the spring. So
That was a pit crew code where we use a motor directly controlling. So you can control the motor one direction is going up, your finger off, the motor, it will slide going down, and then you have a reverse way to moving down. But then in actual competition, we are using which mode?
yeah, base tele off.
Yeah, but then what mode we use on the motor?
It's run to position, and it uses like the PID loop internally to hold it at a certain level and get there at like fast speed. This. Go up. We have preset levels for each height we need to go to, so the driver doesn't have to spend time figuring out how high to go.
So the driver just need to remember button, button, button. It will just move on next, next, next. And all the position has been tuned. And this run to position actually internally has a PID controller. So last season, the team also learned how to tune the internal values to achieve the best behavior. Byron actually tuned all this position in the last season. Okay. Okay. What time is it now? Okay. Maybe we take any question later, not now.
So we're going to move on to Byron's section, which is the robo. Byron, you're muted.
Audrey, can you let me share my screen?
Okay.
It said host disabled participant screen sharing. I think if you look in participants, there should be an option to like allow participants to screen share.
Wait, can you try again? It should.
It still says it's disabled. Like on the bottom bar, there's like participants, and then participants can screen share somewhere around there.
I know it says like one
Security.
participant can share at a time. I have that checked.
Oh, so is someone sharing it?
Oh,
No.
okay, wait. Try again.
Okay, perfect. Thanks. Okay, so welcome to Robocode. Today we will be doing, yeah, this is just a clips. Today we will be doing custom events. So custom events. You can set custom events in Robocode to trigger when something happens. Let's try to create an event that happens when we are at low energy. So basically, you know, let's open up Robot Editor and open up just the most basic My First Robot. So, perfect. All right. So you know, in normal Robocode robots, you have a lot of different default events. Like on scanned robot triggers whenever your robot scans another robot with a radar. On hit by bullet triggers whenever your robot is hit. So these are all event handlers that you can edit to make your robot respond in different ways to different things. And if you want to know more about these, then that was our lesson. A few lessons back. You can find it in our old lessons page back here. But you can also create custom events to trigger when something that you decide by yourself happens. So today, let's try to create a custom event that happens whenever our robot is at low energy or low health points. So to declare an event, let's create a brand new robot. We're going to call it custom event bot. And then remember that we recommend your package name to be just your initials because it's easy. It's short, and it's really brief. Package. All right. So this is our brand new custom event bot. And the first thing we need to do is we need to declare this custom event. So how you do that is you use the add custom event function and you add a new event. Add custom event new condition. And all this code that you see here is going to be on our slides that we're going to be sending out after. So if you want to take another look at it, you can. New condition, low health. Oops. New condition, low health. And then inside, so you can see that we're making a new condition, and this condition is going to decide what our event responds to. So inside your condition, you need a function called test. And this test is going to return whether your event is going to trigger or whether it's not going to trigger. So here, let's say we're going to return get energy. Remember, get energy gets you the current energy of your own robot is less than or equal to 30. So basically what this is saying is it's going to return true whenever the energy of our robot is less than 30 or equal to 30. And so this event low health is going to trigger whenever our robot's energy drops below 30 and our robot gets to low energy. So after we've added this event, we need to add a handler for this event. So that's going to be the next slide. So again, we have our normal robot handlers called onScanRobot. And then here, let's add the event handler to our custom event, which is just going to be public void on custom event, and same thing, same as the others, you're going to want to pass in your event object E. So this E is going to be telling you a lot about the custom event that triggered it. Just like you can use E here to say, to find what the energy value of the scan robot is. You can use E here to find out some stuff about this event that was triggered when on custom event. So let's add something to the console. We're gonna out.println e.get condition .get name. Okay. So this so let's break this down. So we're gonna be printing out something, and that's going to be the condition. So e.get condition. Remember, E is the custom event that triggered this event handler. And then so that custom event is gonna be here. And then we want the condition of that event. So remember, the condition is what's inside here. So e.get condition is basically returning this condition, and then get name. So the name of our thing is going to be what's inside the parentheses of our condition. So this one we named low health. So get name is going to be low health. And so whenever this is triggered, it's gonna print out the message low health. And then we want to do something else. So this is just we're gonna set it red. We're gonna set the color of a robot red to represent that our robot is low in health. Obviously, if you're going to be using custom events for for programming your actual robot that you're going to be sending to tournaments, you want it to actually change something in your robot's behavior, not just change its color. So you're going to be wanting to add your own things here to trigger whenever your robot gets to low health or whatever you set your event to be. So, but for now, we're just going to make our robot turn red. All right, so let's save this custom event bot. Let's compile it. Color cannot be resolved. Yeah, that's because I didn't import this. So now let's compile it. And then let's put it in a battle. So new battle, we're going to remove all our old robots, and we're going to test out our brand new custom event bot. And then to test it out, we want something that will get it to low health. So I'm just going to pick like Tracker, one of the sample robots. You can basically pick any robot that'll fire at a robot, and it'll usually get the job done. So let's start this battle. And then we want to be paying special attention to our console, because remember, that's where we're going to print out a message. So you can see here that instantly a bunch of low health messages come in. And that's actually because whenever you don't just trigger it once when it drops below 30. Once you drop below 30, it's going to be constantly triggering this, because it's always going to return that its energy is less than 30. So let's try to fix that. Let's end this battle, and let's go back to the source editor. So we want our event to only trigger once when our robot is at low health. And there's a lot of different ways you can do this. You can, there's a function called remove custom event that completely removes it. But we're just going to do something a lot simpler, and we're just going to use a flag variable. So using these is something that's actually pretty common in code, like not even outside of Robocode. So this is going to be useful wherever you are. So we're going to want to create a variable that that detects when we've triggered it. And once we've triggered this low health condition, once we printed out that our robot is low health, we don't want to be triggering it anymore. So we're going to be creating a new Boolean variable. So let's just declare Boolean triggered equals false. So starting off, this is false, which means our event hasn't been triggered yet. And then we're going to turn to, and then we need to make sure that we're only triggering this event when this trigger is actually false. We only want to trigger it once. So the exclamation mark encoding usually means not. So this means not triggered. And these two and signs mean that both these expressions have to be true. So even if get energy is less than 30, if triggered is not true, or in other words, if triggered is true or it's already been triggered, then this won't go off because this will return false. And then after that, we just need to make sure that triggered is set to true whenever we print out this on custom event. Triggered equals true. So let's save this and compile this. So basically, this is going to start false, and then the first time our robot's energy drops below 30, it's going to return this. It's going to return true, and this is going to fire. So it's going to print out something, it's going to set it red, and then triggered is going to become true. It's already been triggered. And then after that, this won't resolve anymore. So it should only happen once. So let's test it out. Let's go back here and start the very same battle with our custom event bot and our tracker. Let's start it, and let's open up this. Pay attention. See, you can see that right when it drops below 30, it turns red, but now it only says low health once. Right. Oh, and this is something, if you really want to keep your robot's color in mind, it looks like your robot's color stays the same between rounds. So if you set it to red in round 1, it's going to stay red all of round 2. So just a little something interesting. All right. So are there any questions before I move on later? I have to go, thank you. Where do we get the robot editor? Can we download it? Is it free? Yeah, the robot editor should come with Robocode. And if you don't have Robocode already downloaded, there's download instructions in a document that we'll be sending out in our email. And you can also find it in our later slides. So this is something I want to go over. Here in this link, you can find the link in the slides we're sending out. You're gonna find all the previous videos and all the previous slides we had. So you can see, you can get caught up on all the previous lessons we had if you missed any of it. And that's where you'll find the instructions to install Robocode or install Java or things like that. Yes, you are going to get the slide in the email. Okay, so if there isn't any questions about the actual code, then I'm just going to point you to here, improving your events. Check out the target sample robot. So no RoboWiki link this time because there actually isn't one for custom events, but we do have a very useful sample robot. Remember that sample robots always are pre-downloaded with Robocode, so you always have access to all these robots. So let's open up Target, and Target is actually a sample robot that has its own custom event. So we can see that here it has a custom event, the exact same. So if you want a close-up look at how you declare a custom event, what kind of syntax you use, you can just look at the Target sample robot, and it'll have what you need. Okay. And then one last thing to note about custom events is that you need to be an advanced robot to declare them. So let's say, for example, this custom event bot. Oh, really? Never mind. I guess you can declare when you're a normal robot. But something important to remember is that you can change your robot to an advanced robot, and this lets you use a lot of different functions like set turn, set forward, and things like that. So it's usually best to make your robot an advanced robot once you figure out what you've been doing, because it opens up a lot of new methods for you. Besides that, besides that, all that's left is the robot challenge. Create custom events. So this week's challenge is to create a lot of separate custom events for 75, 50, and 25% health. Make it change colors and add different types of behavior for each health amount. So if you want more practice with custom events, then you can try this challenge and try to make a robot that fits this. And if there's nothing else, then we're gonna be starting the tournament really soon. I just want to talk about a few things. This is the same slide as before. Remember that if you win one of your division's tournaments, then you're gonna be expected to talk about your robot. And so I'm gonna be opening up your robot's code, and you're gonna be talking over it and going over it, just to help all of us learn some new tips and tricks about Robocode and coding in general. Yeah. So one last thing before we move on to the tournament, I have a few things to talk about for the submissions. Okay, one, let me walk through the submissions process because a few people actually emailed me with asking because they had trouble submitting their robots to the form. So let's try to go over a quick submission to the Robocode form so we can make sure that everybody gets their robot submitted and they're all working. So coding experience, you either pick Division 1 if you're new to coding, or not necessarily Java. Pick Division 2 if you've coded before. It doesn't have to be with Java. This is kind of misleading. But if you've coded before, if you think you know what you're doing, at least on the code side of things, then you pick Division 2. And typically Division 2 robots are a bit more advanced. And then here's the part that confuses some people. Submit code file. So you want to add a file. So add file from your device. And then what you want to do is you want to go to your local disk, or if you're not in Windows, you need to find your Robocode folder, wherever that is. And then you need to go to robots and pick a robot. And this is really important. You don't want to pick the class file. You want to pick the Java file to submit, because we can't compile if we're just given the class file. So what you need to do is pick the .java file of the specific bot you want to submit, and then open it and click upload, and it'll upload your file. And then once you turn in the form, we'll be able to get your robot. And then one last thing I want to talk about, make sure you keep the name of your robot the same as the name of your Java file. Otherwise it can be confusing, because the name of this is what's going to show up on the actual battlefield. So if the name here is different than the name of the actual file, then they're going to be called different things, and it can get confusing in the tournament. And then some specific things. Oh yeah, make sure if you have any extra classes, like for example, last week we had Isaac's robot that had the advanced circular target class. You need to make sure to insert your extra class in the same file and the same .java file as your main robot. Otherwise, we won't have access to that class, and then we won't be able to compile it. So if you don't know what I'm talking about, don't worry. You probably don't have an extra class in your robot. And then duplicate robots, a quick reminder. You can submit more than once if you suddenly decide that you want to change what you submitted, but keep in mind that I'll always take the latest one. So make sure if you submit something and it's the last one you submitted, make sure you know that that's the one that's going to be going into the tournament. Yeah, because there's been a few duplicated robots, and I want those people to make sure they know which of the robots is going in. Also, Adrian, yeah, I can talk about you with that after the form. So can Adrian and Selena, if you're listening, can you please stay for the Q&A after this? I just want to ask you guys a couple questions because I was confused. Anyways, with all that out of the way, let's finally move on to what you've all been waiting for, the weekly Robocode Tournament. So you can see that on the doc the dock I was on, we have the tournament schedule. So in Division 1, there's going to be 5 people, which means we're going to be doing the same thing we did last week and selecting one of those 5 randomly to get a bye. And then the other 4 will go to qualifiers. And in Division 2, there were only 4 robots, so we're just going to go straight to finals, and then the winner of that one round will be the winner of the entire Division 2. So let's start things off with Division 1 qualifying rounds, and let's pick a random robot, random number. We're gonna pick a random robot to get a bye and automatically move to finals. So Mochi, it looks like the 3rd robot, automatically gets a bye. So Division 1 qualifiers is gonna be Beast Mode, Mojo Jojo the Destroyer, High Tober, and Sting. So let's start this battle off. Oh, yeah. Annotate. Disable participant invitation. Yeah. All right, perfect. Okay, so Beast Mode, Hightober, Mojo Jojo the Destroyer, and Sting. Let's make sure it's 1 round for qualifiers. And let's start the battle off. Okay, so actually, a lot of bullets flying around, but not a lot of robots seem to be getting hurt. Looks like Hightober though is heavily damaged. It's down to only 10 health. Beast Mode is actually really healthy, still at about 90-ish energy. Hightober gets disabled by running out of energy, and now only a few seconds into the match, it's just Mojo Jojo the Destroyer versus Beast Mode. But a lot of their shots seem to be going wide. So it's just a battle of who can hit the most shots. And it looks like Beast Mode still has the lead in energy. If they keep this up, Mojo Jojo is going to be the one that's going to get disabled first. And it looks like that's what's going to happen. Mojo Jojo the Destroyer gets disabled, and Beast Mode fires the shot and wins the Division 1 qualifiers. Because we have this amount of people, only the person that placed last will actually be eliminated, and the top 3 people will be going on to finals. So actually, Beast Mode, Mojo Jojo the Destroyer, and Hightober are all going to the Division 1 finals with Mochi to determine the true winner of Division 1. So let's do that first. Let's do that first before we move on to the Division 2 finals. So new. So we're going to be removing Sting, and we're going to be adding in Mochi that got a bye. And this is going to be 3 rounds because it's a final round, not 13. And let's start the battle off. Once again, a lot of bullets flying on the screen, but not a lot of robots are actually being hit. Looks like a lot of Division 1 robots need to work on their targeting. But things are happening. Looks like Mochi has already been destroyed, or that's Hightober that's been destroyed. But it looks like Beast Mode is soon to be disabled, and the battle is already over. It's time for round 2. It's a quick battle. Now in round 2, Hightober looks very damaged, but Beast Mode is actually not doing well either. Mochi is right now the most powerful. Beast Mode gets disabled, and now it's just Hightober and Mochi. Mochi's just spinning around in a circle. It doesn't look like its radar has locked on to Hightober yet, but Hightober, its bullets don't seem to be hitting at all. If this keeps up, Hightober is just going to be disabled. And Mochi keeps spinning in a circle. Hightober can't hit Mochi and gets disabled. And now it's only a matter of time before Hightober is destroyed from that inactivity. And that's round 2. This time, beast mode looks like it's getting heavily damaged again. It gets taken out really quickly. A lot of the other robots are still around 70-ish health. But none of them seem to be getting very damaged. Hightober, though, taking a couple hits. Looks like both Hightober and Mojo Jojo are pretty low. Mochi got stuck again and it's circling around, but that doesn't matter because none of any robot's shots can hit it. Any of the robot's shots can hit it. And so it's just circling around now, and it's just gonna take the win from inactivity against Hightober unless, oh, it looks like Mochi's gotten unstuck and started firing again. That's gonna be its downfall. It stopped circling and it got shot down. However, Mochi is going to be our Division 1 winner with 704 points. Beast Mode is going to come in second place with 454 points. Hightober is going to come in third place with 379 points. And Mojo Jojo the Destroyer, unfortunately, is going to come in last place with 310 points. Okay, good job, everybody. Let's move on to the Division 2. So Division 2, there's only 4 robots, so we're going to move on to finals straight away. And it's going to be my second robot versus Nathan's, I'm just going to call it QWERTY, Big Fig by Alex, and Panzer by Adrian. Let's start things off. Three-round finals. Let's go. Oh, so right at the very beginning, 3 robots get in a crash. They both get taken. 2 of them get taken down. Big Fig is soon to follow, leaving Panzer the clear winner. It looks like QWERTY ASDF is Nathan's robot. It's actually a Rammer robot, the same as the 4. But it looks like it's not doing as well as Rammer used to. It looks like, was that Panzer is going to take the win in round 2? But these rounds are going really, really fast, and my second robot is going to be the winner this time. That was a really fast set of matches. And in the end, rank 1 is going to be Panzer with a score of 751. Rank 2 is going to be my second robot with a score of 640. Rank 3 is going to be QWERTY with a score of 410. And last place is going to be Big Fig with a score of 357. Okay. Good job, everybody. Good job on your robot submissions this time. Let's now have the winners of each division talk about their robots. So first, can we have Michelle, the coder of Mochi, speak? Michelle, are you there?
Yeah.
Yeah. So can you talk about your robot a little?
So basically, I put the set turn radar double positive infinity thing in the while true loop, so then it can loop that. And then I added the spin thing by set turn right 10,000, and then the set max velocity 6 and ahead 20,000.
Oh, so this is just supposed to be in a circle. Yeah.
Then on the bottom, I tried to, when the energy got low, I tried to make the firing power lower so that it wouldn't waste the energy. And then underneath that, I did the radar stuff, so then it made it.
Yeah. So this is actually the radar lock-on technique. I'm pretty sure. Yeah, this is the radar lock-on technique we used last time. And it's also the dodging technique that we went over last lesson. So it's good to see that you're putting the code from our lessons to good use. And yeah, so it looks like when it moves in a circle, a lot of the Division 1 robots can't really aim to hit it. So if you just make your robot move in a circle, it's gonna miss a lot of, it's gonna make a lot of bullets just miss it. And then yeah. An important thing to note is that it takes energy to fire bullets. So you can see that sometimes robots got disabled because they fire too many bullets. and their energy dropped below 0. So what Michelle was doing is she tried to save energy by only firing low power bullets, which don't use a lot of energy when her energy got low. So that's really good. Really seems like you put a lot of thought into your robot and a lot of different techniques. So good job. Okay, let's have Adrian. Adrian talk about his robot Panzer, the winner of Division 2. Adrian, are you there?
Yeah,
Yeah. Can you talk about your robot?
so pretty much I just made my robot go to, I have the radar lock, so it will go to whichever robot is
Wait, I'm sorry, I can't really hear you well. Is anyone else having this problem?
Yeah, your audio is a little bit.
Yeah, can you try to like speak up or adjust your microphone? I'm sorry, I just really can't understand you. Errors requesting remote control of your screen? No? Can you type it? Are you wait, are you Adrian? Yeah, I mean you can, but it'll be pretty slow. Yeah, I guess you can type it out. A couple of things if you really can't get your mic working.
Wait, is he able to share his own screen or no?
Yeah, you can share your screen if you want. Do you want to do that, Adrian? Oh, you could type it. So are you just gonna type
Yeah.
it in chat? Are you just gonna type some stuff in chat? Sure. Okay. Yeah, that works, I guess. Yeah. So just tell us a few things about your robot. So how does it move? How does it fire? How does it dodge bullets? Yeah. There's a lot of stuff in here. Made a radar lock so my robot would go to its future location. Okay, yeah. So here's actually the radar lock that we went over a few lessons ago, and that's actually the same radar Michelle was using. So it's actually a really effective radar technique even in the high levels. Yeah, and then kind of go in circles around the robot and fire at it. If they can get close enough, it'll try to ram the robot. Oh yeah, that's interesting. I guess that's why you had those jumbles of 3 robots in Division 2, because there were 2 robots trying to ram both your robot and Nathan's robot. Um, is here the code for ramming? It looks like it is. If the distance is less than 300, then uh then it'll try to ram with all this code. Yeah. So did you write all this code yourself, or did you get some code from from some other robots? Because I know a lot of people are scared by this amount of code, but don't be. It's okay. It's okay. You don't have to write everything yourself. You can take some code from other robots. Yeah, I got the targeting from RoboWiki. Yeah. So you can take code from RoboWiki and use it for your own robot. Just make sure you understand what you're doing, and it's always best to try to edit that code. Don't copy paste it, but actually try to look into that code, understand it, and try to make your own edits to make it behave exactly the way you want to. Yeah, but you definitely don't have to write all this stuff yourself. Yeah. Anything else you want to talk about your robot? Yeah, something interest. Also something interesting I know noticed is that Nathan, it looks like you have like the same gamer robot from last time, but you changed the name. I remember last time Last time, some people tried to target the rammer specifically by name. So they were checking if the scan robot had rammer in its name, and you changed your name now. So I guess that doesn't work anymore. I don't know. I just find that funny. Okay. I mean, Adrian, do you have anything else to talk about your robot? Okay. If there's nothing else, then it'll change direction if it senses the enemy has fired. All right, let's see. So I'm gonna try to find where. Get energy. And the less than 300 part. Yeah, okay. Else if. God, there's so much text. Ah, here it is. If it's less than 300. Yeah, here. So this is actually the same thing we went over last time when we went over how to dodge bullets. You have a variable called previous energy that tracks the last energy of your scan robot. And then if it changed, then that probably means that robot fired a bullet. Because firing a bullet takes some energy. So if it changed, then you assume that they fired a bullet, and then so Adrian's robot moves in the other direction to try to dodge that bullet. Yeah. So again, they're really simple in theory, but if you use these tricks in the right way, then you can get some really good results. Yeah, like Adrian did. Okay, so don't forget to answer the PID question from Coach Guru. I don't think that was for Robocode. I'm pretty sure that was for I'm pretty sure that was that was my that was my tuning of the robot. So in this case, did the I matter more than the D in the beginning, or are you using multiple phases for the D to kick in? When I was tuning the PID, I usually try to. Well, the way I learned how to tune PID was I tuned the D before at the very beginning, and I only changed the D value, and then I kept doing that until it was like really close, and only then did I changed I'm sorry. I changed P before anything else, and only after that did I change I and D. And I don't think I actually touched D for the lift. I only used P and I. So I guess I did matter more than D. But I think P is the simplest, and it usually just matters the most. There's no need to think too hard.
Thank you, Barry. That's a good answer. Thank you.
Yeah. No. Targeting, not PID. I was answering Coach Gu's question, like upwards about that he asked when John was presenting. Is there any questions about actual Robocode? I guess right now we're on to the Q&A already. So if you don't have any questions, then you're free to leave. But if you do, just ask questions in chat. I'll be staying. Are you allowed to use some things? Yeah, sure. Again, you can copy code. It doesn't have to be all your. You can like take stuff from code. It doesn't have to be all your own code. But don't copy. Don't like Control C, Control V it. You have to make sure you understand the code, and you have to make sure you have to like actually understand it and make your own edits. Important thing to note, sample robots definitely aren't like the strongest robots. So even if you do copy and paste an entire sample robot, don't expect it to do very well. Yeah. Bye. Yeah, bye. Oh, one thing I wanted to talk about actually, Adrian. I mean, sorry, not Adrian. Not Adrian. Yeah. Adrian and Selena. Selena. Yeah, your Joe the Destroyer says it's also from Adrian Lin, and it's in the package AL, but the name of the coder in the form says his name is Selena. Oh, Selena is my sister. Oh, I see. So is she in the same package as you? I'm just confused as to why it says Adrian Lin here. Oh, I mean, I see. Yeah, I thought you submitted like two of the same robot. She also uses the same computer. I mean, even if you do use the same computer, you don't have to name the files Adrian Lin, right? Yeah, you don't even have to be in the same package. Yeah, if like I can create a brand new package, source editor, new. Like you don't have to always stay in new. You don't have to always stay in BL, like new package. So you can have your sister make her own package and name your file. Yeah, name your file different things so that they don't get mixed up. Anyways, I mean, it's nothing much. It's nothing much. Is there a base, a code you must have, or is it all what you want? So when you extend this robot, there's a few things that have to be in there for it to function, but most of it is what you want. So if I make, let's open up, this is my first robot. So usually, actually, I think this is a brand new robot, and when you make this robot, there's a bunch of stuff that's already here, and this is basically all you need to get started. You need to be extending this robot, and you need to have this run function. But so you need to have like the main methods defined, like this public void run. But all this stuff is entirely up to you. Like, yeah. So this is the base kind of, and then yeah, you must have that part, right? Or you can edit all. Yeah, it's usually best. You need this and these. Yeah, so it's usually best to just keep those parts. Whenever you make a new robot, this is the default that it already starts with, and then you can edit what's inside of it. But keep this stuff in. Yeah. Thank you for joining today. Is there any other questions? I don't think the change velocity random part is really looking at because the maximum V is defined in rules. Yeah. Yeah. So this is actually just a small thing. So let's open up. So there's maximums. There's like a maximum bullet power, like a maximum velocity, and a bunch of random things that are already predefined by Robocode. So a lot of people, they do like fire bullet power like 1,000,000 or something like that, and what that actually just fires a bullet at power 3. So I mean, that's just something you should keep in mind. The maximum bullet power is 3, and there's other maximums too, like set max velocity 12 multiplied by math at random. Yeah, there's a maximum velocity. It's like 6 or something like that. Yeah, so
That's top to 8. So I don't think this works.
yeah, 8. So 12. So it's always just gonna be setting it to 8 because it's always gonna be bigger than 12. Yeah. So that's just something to keep in mind. Coach Q, do you know a place where you can find like all those limits, like all the rules?
Yeah, in the API doc, there's a class robocode.rules. It has all the constant values there.
Okay, class. Oh, I see it. Battle rules.
Probably not this one. This API to get it, but there is a constant class container that is just robocode.rules.
Ah,
Yeah.
I see it. It doesn't say the values though.
Yeah, the values, if you just click on max turn rate or max velocity rate, it has the values there, like 8. Yeah.
Oh, yeah. Radar scan radius is 1,200. Minimum bullet power
The max velocity is above
is
8
this.
per turn.
Yeah, it's actually really useful. So I'm just gonna link this in the slides. I'm just gonna link this in the slides and improving your events. And this link, this link for yeah. So you can try to keep some of those values in mind. Keep some of those values in mind and plan your robot around them. Yeah, so that's really helpful. Thanks, Coach Crew. Okay. Is there any other questions? Okay, I'm just gonna stop screen sharing. Okay. I mean, if there's no other questions, Audrey, we can just
Yeah, you
end the Zoom
guys
session now, right?
feel free to leave. Thank you for coming again. We're going to send a follow-up email after the session, and we hope to see you next week. Thank you.